Okay, so let's continue. Uh, Last time I gave you a few questions for homework. Um, I hope you would have done those. We're going to discuss the answers and then we will continue with the next topic. Okay, so let's begin. Uh, okay, 7th standard. All right, here. All right. Can you all see the questions on the screen? Okay. All right. Let's start then. Let's start. So we're going to start at this question number one, right? So this question is related to motion with a constant acceleration. All right. Let me ask you the answers quickly. What is your answer of A? What is your answer of A? Uh, I'm better today, right? I'm better than yesterday. Yeah. So what's the answer of A? Thank you so much for asking, everyone. What is your answer of A? Unit, everyone, please write the unit. Right, thank you, Divya. Okay, we're getting different answers. All right. Hmm. Okay, fine. So I've noted what are your answers. Now let me solve this for you. I don't know the answer, very frankly. I've not solved it. Right. We will do it right now. So let's see what happens. So first of all, it's again, see, like I've always been insisting, it is very important to draw diagram, right? If you don't draw diagram, you're going to not understand a lot. So the question says that there's a 900-meter long straight racetrack, right? Okay. And the cars A and B start from rest and move with a constant acceleration and 2 meter per second square, right? So let's say here is car A, and along with it there's another car B, right, over here. Okay, so now both are starting from rest, so both have initial velocity 0. Right, now find the time difference with which car B wins the race. So let's say here is the finish line, right? Okay, so this displacement is of course 900 meter, right? The displacement is 900 meter. So we have to find the time time difference. All right, that is how much time does B take and how much time does A take. We have to find the difference. This is our answer, right? So to find out the time, we are going to use the second equation of kinematics, right? I hope everyone did that. We're going to use the second equation of kinematics. So this will be as follows. Second equation of kinematics, 900 is equal to, now I'm doing this for A right now, then we will do it for B. V0 t plus half A8 t squared, right? Acceleration of A. Okay, so you're getting that 900 is equal to 0 because V0 is 0 plus 1 by 2 into 1 into t squared, right? So that will give me that the time for A t is equal to 1800 under a root. All right, so that is 30 root 2 seconds. All right, this is not the answer. Mind well. Mind well. This is not the answer. This is only TA. That is time taken by A. Now for B, we have to do similar calculation for B. I'll just rush through it very fast. All right. Because AB is 2. Instead of 1, here you're going to get 2 T squared, right? The rest is all same. So this is for B. So for B, you're going to get TB equal to 30 seconds. All right. For B, you're going to get TB is 30 seconds. So finally, finally it is that the answer is going to be Ta minus Tb, means 30 root 2 minus 30. So if you're writing it in, this kind of form, this is your answer in second, right? Otherwise, you could put root 2's value. I'm sure you all know that it is nearly 1.4, correct? So if you do that, then this is close to 12 seconds, all right? So that's your answer, okay? This is close to 12 seconds. Yes. Okay, so that's it, right? Now, B part of this same question. B. When the car B finishes the race, what is the distance between the cars? So at that time, you have to find what's the distance between the car. Again, draw a diagram. Suppose B finishes the race and at that time A is here. All right. Let's say when B finishes the race, A is here. So we have to find the distance between them, right? So do you realize that this is the situation when time was 0 and this is the situation when time was 30 seconds, correct? All right, because B finishes the race in 30 seconds. We have just found that out, right? So we want to find that distance. So the plan is that in 30 seconds, if I find out how much does this move, right? And then from 900 I can subtract it, so I'll get the answer, right? This is actually our answer, right? I hope you realize this is our answer. So from 900, if I'll subtract that delta x, I'll get the answer. So this is going to be as follows. In 30 seconds, displacement of A is delta x equal to v0 t plus half a t square. Now this we are doing for A, all right? So v0 is 0, half 1 into 30 square, right? So this is going to be 450 meter, all right? Is that okay? So ultimately, the final answer is, listen to this carefully. The final answer is that when B finishes the race, that is at 30 seconds, A is only at how much? That's what we have found. A is only at 450 meter. So this remaining distance is of course the remaining distance between them, right? That is between A and B, right? Is 900 minus 450. That is equal to 450 meters. All right, that's your answer, 450 meters. Yes, Priyansh. Okay, so that's it. Clear? This is the proper method. 230 root 2. Okay, good thing. Listen to this. Read the question carefully. The question is when B finishes race, what would be the time when B finishes the race? I'm okay. Kashyap, I'm okay now. I asked you when B finishes race, what's the time? Yes, it's not 30 root 2, all right? It is 30. I hope everyone realizes why I'm putting 30 here, all right? Okay, because we have to find when B finishes race, what is the distance, right? Correct? 60? Come on, Dikshita. 30, 60 can be. All right, so this is it. Clear? This is the method. Okay, so hopefully this question would also have helped you understand that physics is not just maths. It's a bit more, right? You have to understand so many things. Can we find the second answer by delta x equal to Princey? What is that 10 for? 0 into 10? What is that 10 for? And this is what I've done, right? This is not Sorry, over here. This is what we are talking about. This is what we have done. This is 450. Remember, although this is 450 and this is also 450, this is not the answer. I hope you realize why. Because this is only the displacement of A from here to here. That was never the question. The question was how much is the distance between the car A and car B, right? This is the question. So it's actually a coincidence. You understand what our coincidence is? Right? This is actually a coincidence that this is 450 and this is also 450, right? It has happened because acceleration of A is 1 but acceleration of B is 2, right? That's why this coincidence has happened. All right, fine. So I think that's enough discussion for this question. Okay, let's go to the next. So here we are given a VT graph, all right, and you have to find out A, what is the type of motion, right, between 0 and 5 seconds. What do you say? Come on. What's your answer? What is the type of motion? Okay. Motion cannot be positive and constant. Motion cannot be straight line. No, 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 no. Many of you have given wrong answer. There are two correct answers, right? There are two correct answers so far. Yes, very good. See, everyone, the answer of this A is uniformly accelerated motion. That's the correct answer. It is uniformly accelerated motion. Have a look at velocity. I want all of you to look at this graph very carefully. Right? This is a motion is not increasing. Motion is not something that can increase, please. It's not uniform motion. Come on, people. Tell me the definition of uniform motion. Write what is meaning of uniform motion. Can you please write that, everyone? What is uniform motion? What is uniform motion, everyone? What is uniform motion? No, Jay, wrong. No, Jay, kid. That is childish. Exact. No, Nemi. Yes, Preet, that's right. What, Sahil, what constant? What's constant? Come on. No, Falak, motion which is constant is not uniform motion. Yes, okay. See, everyone, I want I want this to be very clear in your mind. Okay, listen to this carefully. Many of you are still making some mistake with it. Uniform motion means only this. There is no other option, right? Okay, there is no other perfect thing. Uniform motion means motion with constant velocity. Motion with constant velocity, all right? Velocity should be constant. That's called uniform motion. And by default, that means acceleration will be 0, right? By default, that would mean acceleration is 0, all right? No, Dhruvanshi, that will not do. Covering equal distance in equal interval of time is not uniform motion. Ananya, no, that's not correct. No, Krisha, not correct. Okay? Not correct. Is that clear? Constant speed is also not correct, everyone. See, so many of you have written that it travels equal distance in equal time. Travels equal distance in equal time. This is wrong. Okay? This is not called uniform motion, right? Because this sentence means uniform speed, but uniform speed is not same as uniform velocity, right? Okay, so everyone be a little bit careful. What we have learned in ninth is not perfect, so it's wrong. This, what I've written over here, is the complete thing. Motion with a constant velocity, right? Or you could say that with acceleration 0. That's called uniform motion. All right, so please be careful. Okay, so now let's come back to this question. Here you can clearly see the velocity is changing, isn't it? Because in ninth standard you all were little bit younger, you didn't know a lot of maths. At that time you didn't even study the definition of velocity, correct? Okay, right? I hope you understand what I'm saying. Did you study v is equal to dx by dt in ninth standard? If that was the case, most of you would have failed in ninth. Think about ninth standard students would having to study differentiation, right? બચારા નાઇન્થ થી જ ઉઠી જાય, ઘરે વયા જાય, નથી ભણવું અમારે. Am I right or not? અહીંયા તમને ડિફરન્સિએશન ભણવું પડ્યું તો એ અઘરું પડ્યું કે નહીં? તો બચારા નાઇન્થ વાળા તો ઘરે, ના ના અમારે આવું જ નથી, સ્કૂલ જ નથી આવું. So what I mean to say is, at different standards you are taught different things, right? And gradually as you grow up you go and study more and more correct or perfect things, right? But here this one ends, right? Nobody is going to tell you any other definition of uniform motion now. This is the final. All right, okay, this is the final, right? This is the correct definition. આનાથી આગળ કઈ નહીં આવે ક્યારે. Okay, so let's come back to this question. Here you have velocity 10, then gradually it increases, becomes 20. So what do you think? Look at the slope of this line. It's a constant, isn't it? There is a constant slope. I hope you understand what I'm saying. And slope of VT graph gives acceleration, right? This has a constant slope like this, right? So that's why acceleration is constant, because the slope is constant. All right, and in VT graph slope is acceleration. I hope all of you remember that. So the answer of this A question is uniformly accelerated motion. All right, that's the correct answer. Okay, did you understand, everyone? See, it's very similar to this. Just a minute. Do you remember that if you have a straight line xt graph, what does this mean? What does this mean? Straight line xt graph, what does this mean? What does this mean? Yes, very good. Constant velocity, right? It means constant velocity. The reason is that v is equal to dx by dt, which is equal to slope of tangent of this graph, right? Slope of tangent of xt graph, right? Similarly, think about VT graph. Okay, suppose there is a VT graph, and that VT graph is a straight line. So just like here, slope of tangent is velocity, similarly in this case, slope of tangent is acceleration, right? So this has a constant slope, right? Because it's a straight line, it's not curved. So that's why this is going to be constant. All right. Okay, so what happens is, yes, in xt straight line means constant velocity, but in vt straight line means constant acceleration. All right, that's what is going on. Okay, fine. Coming back to this question. Okay, where did that go? Is this the question? Sorry. Okay, yeah, here. All right, so here it is. So the answer of this one is constant acceleration or uniformly accelerated motion. All right. Okay. Now let's go to part B. Part B. No, Raj, constant acceleration does not mean constant velocity, right? Motion with constant velocity is something else, and motion with constant acceleration is something else. Okay, what's the answer of part B? Come on, people. Part B. Meanwhile, I'll erase all this so I'll get space to write. You all type your answers out. Okay, that will give me some time, and in that time, I will remove all this from here. Okay, right, fine. So let me check your answers. Okay, some of you are saying 30 meters, some are saying 100 meters, some of you are saying 175 meter, 200 meter. All right, let's check. Let's check. Now, the question here is, what is the distance? What is the distance before turning back? Turning back means moves in opposite direction. So first question is, when does it turn back? When does it turn back? Come on, when does the particle turn back? Can you answer that? When does the particle turn back? When does the particle turn back? Yes, very good. At 15 seconds. All right. Particle turns back at 15 seconds. Right. Okay. See, the idea is this is VT graph again. So here everywhere the velocity is positive till here, right? You can see this is positive velocity, positive velocity. But from this point onwards, here the velocity is negative, right? Okay, I'm not talking about slope because this is VT graph. All right, this is VT graph. I'm not talking about slope. I'm just talking about velocity. So here the velocity is 20, which is positive. Here it is like 10 positive. Here also like 10 positive. But over here it's negative. So it means particle turns back at 15 seconds. All right, that's the first thing to note. Now we can find out. Now we can find out what is the distance travel. All right, so from VT graph we can find distance traveled by the area. So what I'm going to do is I will divide this area into two parts. One trapezium, okay, I'll call it area number 1, okay, and the other one is this, right, I'll call it area number 2. Okay, so let's start. So the final answer is that distance traveled in 15 seconds is area 1 plus area 2. This is what you have to do, right? This is what you have to do. Yes, at 15 seconds, object turns back. Right? So here we are going to find out area of this trapezium. So we can do it very easily using that formula. So that's going to be half into distance between parallel sides, which is 5. All right, this is A1. All of this is A1 plus A2. Now A2 is a simple triangle. All right, it's a simple triangle. So half into base into altitude. All right, half into base into altitude. Is that clear? This is A2. Yes. Okay, so what do we get? So this is going to be 30 into 5, 150 by 2. So that is 75 meter plus. Now this one is going to be 100 meter. Yes. So the final answer is 175 meter. Very good to all of you. It was not a very straightforward question, but still you did it very well. Well done, people. Those who got 175. Well done. Okay. Now part C. Come on. What's your answer of part C? Hurry up. What's the acceleration of particle in positive? When is the acceleration in positive direction and when is it negative direction? When is the acceleration positive and when is the acceleration negative? What? Nowhere. First for positive, where is it positive? Where is it positive? Where is the acceleration positive? We're getting lots of right answers. We're getting some wrong answers also. Okay, the correct answer to this C part is that acceleration is positive. Oh, sorry. Acceleration is positive in 0 second to 5 second. All right. Okay. And then it is negative. That is from 5 second onwards. It is always negative. Okay. Okay, you see. So see, how do we know that? How do we know that? This is VT graph. Everyone, VT graph. VT graph acceleration is given by slope of tangent, isn't it? I hope all of you realize that. Acceleration is the slope of tangent. So you can see where is the slope positive? Obviously here it's positive and over here it's negative, right? So 0 to 5 second positive slope and then 5 second onwards negative slope. All right. Okay. D. In which time interval does the particle have retarded motion? So first of all, tell me what is retarded motion? What is retarded motion? What is meaning of retarded motion? Nahi. Ami, your answer is right. Priyansh, Pinak, read the question carefully. What is decreasing? Riya Singh, what is decreasing? No Dhruvanshi. No forum. No, 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 no. People, what happened to your language? Retarded motion. I am asking you about retarded motion. I am not asking you about retardation. They are different, right? Retarded motion means motion in which speed decreases, right? Okay, motion with decreasing speed. So those who gave such an answer, that is right. And this happens when acceleration and velocity are in opposite direction. Sorry, Gracie, I was writing it, so I couldn't see what was your answer. Velocity, acceleration is in negative to bring velocity equal to 0. No, that's not like that. No, Haley, that is wrong. Motion of a body in opposite direction, nahi. Okay, everyone, this is the only way to write it. Okay, retarded motion. First of all, retard means to slow. થોડુંક English સમજાવી દઉં તમને. Retard means to slow. Okay, this is from dictionary. If you want, you can check it. All right. Okay. Now, slow means what? Decreasing speed. So such motion is called retarded motion. All right. Retardation is another thing. Retardation is a value, it's a quantity. You understand what are quantities, right? Okay, this is not a quantity, this is a type of motion. Okay, retardation is a quantity. What is that quantity? It is equal to magnitude of acceleration. Yes. Okay. All right. Fine. So now, so can you tell me the answer to this question now? D. Come on. Tell me the answer to D. Tell me the answer to D. Okay, very good, Rehan Khan. Well done, Divya. No, Ami, that's not right. No, Gracie. Vandan, 85. What is 85? No forum. After 5 seconds till what? After 5 seconds till what? Till what time? No, Nemi. Okay, everyone. The correct answer is 5 second to 30. Sorry, 5 second to 15 seconds. This is the correct answer. All right. Let me show you why. Let me show you why. Have a look at this graph. We are looking for velocity and acceleration in opposite direction. All right, we are looking for velocity and acceleration to be in opposite direction. All right, so here in this part velocity is positive, agreed? Okay, because this is above the axis, right? A positive velocity is here. So here the velocity is positive, but here the graph is going down, means slope of tangent is negative. So this is what we are having, opposite directions. But અહીંયાથી એવું ન થાય. Here velocity itself is negative and acceleration is also negative, so both are in same direction. Clear? Okay, have you understood that? I want to ask all of you, this is a slightly tricky one, right? Every year people get confused with such questions. I want to ask you that. See, what I'm saying is, if you take this kind of graph, between these 2 points velocity is positive, because here it's like 20 and then 10 and then 0, till here it is positive. But if you look at the tangent in this part, right, it's down like this, agreed? That means acceleration is negative, because acceleration is slope of tangent of this vt graph. So this is what we are looking for. But from this point onwards, velocity itself is negative and acceleration is also negative, both are negative. So that's why this is not retarded motion. Agreed? This is not retarded motion. Clear? People, listen to this. Every physics question is going to be like a puzzle, right? You have to use your brain a lot. You have to recall what are those important points. ઓકે, ઇમ્પોર્ટન્ટ પોઈન્ટ્સ આમ ખિસ્સામાં જ હોવા જોઈએ. ગમે ત્યારે કંઈ પણ પૂછે ને એટલે યાદ હોય. ન હોય તો જોઈને વાંચી લેવાના, રાઈટ? ઓકે, so everyone, the important points are really very important. Like I've said, દરેક વખતે એનો યુઝ થાય છે. I hope you are seeing that. I hope you notice that lots of answers are based on important points, right? Okay, all right then. So that's it. The answer is 5 seconds to 15 seconds. Let's go to next. Here, E. What is the acceleration at 10 seconds? All right, here, at this point. Okay, I really made a mess of this graph. Okay, but see, do you realize that here the slope is same everywhere because it's a straight line, right? અરે હમણાં જ વાત થઈ, acceleration તો negative છે, but how much, Priyansh? Negative, that's right. How much? Okay, what is the acceleration? Okay, so I want all of you to look at this very carefully. Here is 10 seconds, and that point the velocity I think is 10, right? 10 જ છે ને? Okay, at 5 it is 20, and then at 15 it is 0. So do you realize that here, because this graph is a straight line, so acceleration is constant. હમણાં જ વાત થઈ હતી ને, that if vt graph is straight line, that means acceleration is constant. So instead of finding a, I can find this. I hope you remember this, right? So how much is this? So how much is the average acceleration? How do you find average acceleration? How do you find average acceleration? Everyone, how do you find average acceleration? How do you find average acceleration? What's the formula? What's the formula of average acceleration? No, Ayushi. Okay, most of you have given it right. I'm actually quite glad. Bhavya, your answer is not correct. Okay, the correct answer is, if you want to find average acceleration, it is delta V by delta T, right? Delta V by delta T. So let's use it here. Let's put the value. See, again, I'm telling you that we are getting it like this because acceleration is constant. Otherwise, the general formula or general way to get acceleration is dV by dt, right? Okay, so don't forget that. Okay, that. Let's put values. Final minus initial. Let's take, see, you could take any point between 5 and 15 because here it's a straight line. So you take final as 15, all right, makes calculation easy. Final velocity 0 minus, I'll take this as initial and this is fine, all right. Initial velocity 20 divided by final time 15 minus initial time 5. So this is equal to A. So here that's going to be A is equal to minus 20 by 10. So that is minus 2 meter per second square. Minus 2. Clear? What happened? Do you have questions? Yes or no? Can you please tell me? Is it clear? Okay, how is average acceleration equal to acceleration? All right, I'll explain that. Okay. See, I hope you remember I told you that whenever something is constant, the average is also the same. Do you remember that? Okay, so here acceleration is constant because this graph is a straight line, right? The VT graph is a straight line in this part. So acceleration is constant. So average is also the same. That's why average acceleration is equal to acceleration. All right. Many of you have not understood, it seems. Have you understood, people? I've done it with first equation of kinematics. Okay, you can actually do it with first equation of kinematics also. Okay, I will repeat it very quickly. Look at the graph. Look at the graph, everyone. Okay, so what we are having is, I am taking this point as final. This point, all right, when time is 15. So what is final time t2 equal to 15 seconds? What is final velocity? Let's say v2 is equal to 0. I hope you realize that it is 0 here. Similarly, I'm taking initial time as 5 seconds, right, over here. So 5 second initial time and initial velocity 20 meter per second. All right. So this is what we have. Now I'm just going to find out. Average acceleration, because average acceleration is same as acceleration here, right? Because it's a constant. So put the formula: final minus initial, final 0 minus initial 20 divided by final 15 minus initial 5. So how you know? Minus 20 upon 10. Okay. You can also do this by equation of kinematics because you know that acceleration is constant. Final velocity 0, initial velocity 20 plus acceleration A, time interval, T is time interval from 5 second to 15 second. How much time interval? 10 second. So that will give me 10 A equal to minus 20, therefore A equal to minus 2 meter per second square. So this is another method to do the same thing by equation of kinematics. All right. Okay. Fine. I think we should go to the next question now. Here it is. Okay. figure here shows how 0 minus 20 came. Array Prince, initial velocity, final velocity, right? I took final as this point, last explanation. No, I will not repeat it now. I took this point as final. So final velocity is 0. And this point as initial. So initial velocity is 20. Like that I got it. Okay. Now question 3. Figure shows xt graph. At which point particle speed is decreasing, that is retarded motion. Okay, what's the condition for retarded motion? When do you say it is retarded motion, or when does speed decrease? What's the condition? When do you say it is retarded motion? Yes, it should be that velocity and acceleration should be in opposite direction. Very good. Velocity and acceleration should be in opposite direction. Okay. So here we have to find at which point velocity and acceleration are in opposite direction. What is your answer, first of all? You tell me your answer, everyone. Hurry up. What? Tell me your answer. Tell me your answer. See, we are only looking for points. Okay. We are only looking for points. એટલે A to B એવો answer નહીં આવે. This answer is not right. We are only looking for point. Okay, so I see that so many of you have tried something. All right, try કર્યું છે ને કે એમને એમ ગમે તે ઝીકમ ઝીક કરો છો. Okay, now so many of you have answers. All right, so we will make a table. Okay, where we will write velocity and we will write acceleration. We have done it earlier like this. I am sure you remember. Okay, so that will help us decide. Let's start. At a velocity and acceleration. Bolo jaldi. At a velocity and acceleration. At a velocity and acceleration. Hurry up, come on, people. Velocity and acceleration at a. Okay, Falak. Correct answer. Yes, Divya. Correct. Well, everyone, the correct answer is velocity negative and acceleration 0. Constant acceleration, nahi, Neil. Wrong. 0 acceleration. Why? Because I'm sure you clearly see that up till somewhere here, this graph is a straight line. Agreed? Right? In this portion, this graph is a straight line. XT graph is a straight line. That means acceleration is 0, right? I hope all of you remember that. Okay. Okay, B. Now, I'm going to write it for B very quickly. All right? હવે તો તમને આવડવું જ જોઈએ. B velocity is positive and acceleration is also positive. At C, velocity is positive and acceleration is negative. At D, velocity is negative and acceleration is also negative. At E, velocity is positive and acceleration is also positive. So final answer is C, right? How many of you have understood this? Be frank, okay? Yes, no કહેવામાં કઈ શરમ નહીં રાખતા. Be frank. How many of you have understood this? આ બધા yes કે છે ને એમને આવડવું જોઈએ. હું પૂછીશ જ્યારે આપણે મળશું ને ત્યારે. જોજો તમને. પછી જોઈએ તમને આવડે છે કે નહીં. Okay, Vedant, what's your question? At B, velocity will be negative. All right, everyone, xt graph. How do you find velocity from xt graph? How do you find velocity from xt graph? Are you seeing it's retardation if both are in opposite direction to each other? All right, both are opposite to each other. Yes, slope of tangent, very good. So at B, you can clearly see the tangent is like this. So slope of tangent is positive. All right, so velocity is also positive. Clear? Okay. All right, so answer is only C. So how many of you got it right? Can you tell me that? How many of you got it right? Only C. બીજો એકે answer નહીં હો, only C. Okay. Arkan, what do you want to know about C and D? Okay, this is the last one. I'm not going to explain it again. This is velocity positive, right? You can clearly see that because slope is positive, but this is like a bump, right? Bump means acceleration will be negative. All right. Okay, xt graph like a bump, acceleration negative. પતી ગયું, એવું જ છે. Okay. All right, don't worry, keep trying everyone. I'm sure you'll do better as time will pass. Okay, here's the next question. 4. Come on, what's your answer of 4? First of all, is it yes or no about 4th? Is it yes or no? Tell me that. Will the truck hit the obstacle? Yes or no? Okay. Fine. So because all of you are saying it is not hitting, right? So many of you are saying not hitting. Some of you are saying it will hit, right? If it, so those who are saying it will not hit, what will be the distance? If you are saying it will not hit, then how much will be the distance between the truck and obstacle? Ankita, distance will be 70 meter. Are you sure? Okay. Many of you are saying distance will be 10 meter. All right, let's check. Let's check. Here's the truck. Okay, let's say it starts at the point. This is at the point. Oh, sorry. This is at the point A. All right, where its velocity is initial velocity, which is equal to how much? 72 kilometer per hour. All right, 72 kilometer per hour. But in meter per second, that's going to be 20 meter per second. But here is that obstacle. All right. Okay. Right, and let's say in how much distance it will stop, we will find it. So suppose it would stop here. I don't know where it would stop. Okay, let's say, forget about obstacle for a while. Okay, just ignore it. Right, let's say it would stop here. Okay, so here when it reaches B, the velocity is 0. Forget about obstacle. Right, it is invisible. All right, then this final velocity will be 0, right, because it stops. So based on that, you can find out this distance or displacement. How much displacement? we will use the third equation. Okay, third equation is actually the easiest way to do it, right? So 2a delta x equal to v square minus v0 square. Now the question is, what's acceleration? Well, see, acceleration has to be in opposite direction. I hope all of you realize that. So if you say right side is positive and left side is negative, if you'd say right side is positive, left side is negative, then this acceleration will actually be equal to minus 2.5 meter per second square, right? Not plus 2.5. It has to be minus 2.5. V0 will be 20. All right. So now let's put the values. 2 into minus 2.5 into delta x, we don't know, is equal to v square. Final velocity square 0 square. Initial velocity square 20 square. So this is minus 400. And this one is minus 5 delta x. So that would mean delta x is 80 meter. It means the vehicle stops at 80 meter. It means the vehicle stops at 80 meter, right? But the obstacle is at 90 meter. Clear? This is only 80, right? That means it stops. It does not hit. All right. So we have got that it does not hit. All right. But if it does not hit, then what's the distance between them? Obviously 10 meter, right? I'm sure there's no doubt about that now. 10 meter दूर रही जैसे. Agreed? This distance will be 10 meter. Yeah. Okay. So that's it, right? Yes, very good, Nami. That's perfect. Okay, Ankita, I'm glad you did. So this is your answer, all right? Sixth. All right, what's your answer of? Tell me both the answers together, everyone. Tell me both the answers together. What is the speed of car when it crosses A and when it crosses B? Tell me both the answers together. Tell me both the answers together. Everyone, tell me the answers together, both the answers. Okay. All right. Let's do it and then we'll stop. It's that here is that long straight road. Let's say right side is positive and left side is negative. Okay. And here is that person A and here is that person B. Okay. On the side of the road. And suppose here is the vehicle which is moving. Okay. So when the vehicle is at this point A, suppose the vehicle is coming from left to right. Okay. Right. How do I know? I'll talk about that at the end. If the vehicle is going from left to right, right? So this we consider as initial, means when the vehicle crosses A, this I consider initial and time equal to 0. Then vehicle will reach here, all right? That will be 4 seconds, all right? Is this clear? And this is our final situation. Got it? Now, what do we know? We know that displacement of this vehicle is from A to B. That is going to be 100 meter, I think. What did I give in the question? Yeah, 100 meter. All right. So delta x is 100 meter going from A to B, right? Time interval is 4 seconds. Okay. We have to find what's the speed of the car when it crosses A, and acceleration of the vehicle is also given. See, it is given that it is speeding up. Speeding means speed is increasing, right? I think you understand that language. So that means the acceleration is in the positive side, same direction as velocity. All right. So acceleration is +1. Okay, please just give me a couple of minutes more, then we will end this class, right? So we are having that these values, right? Now we want to find what's the velocity when it crosses a, that is what's the velocity here. So what's v0 and what is v? Oh, sorry, not the person's velocity, I'm so sorry. We are talking about car's velocity, right? We're talking about car's velocity. So what's the velocity v0 and what's the velocity v? So we will use second equation, that's right. Okay, because that will give us v0. So let's use second equation. Delta x equal to v0 t plus half a t square. Okay, right? Yes, 23 I think is one of the correct answers. So 100 is equal to, what is v0? We don't know. V0 means at a, don't forget, initial at a. All right, into t, 4 plus 1 by 2, 1 into 4 square, 16, right? So now this will give us 100 is equal to 4v0 plus 8. Therefore, 4v0 equal to 92. And finally you get v0 equal to 23 meter per second. So that means when the vehicle crosses A, it is going to be 23 meter per second. Now we can easily find it for B by using same interval A to B, all right, and using first equation. V equal to V0 plus 80. Final velocity is at B, we don't know. Initial velocity is at A, we know that 23 plus 1 into 4. So this is obviously 27, all right. Okay, I hope everyone understood that. So finally, the answers are velocity when crosses A is 23 meter per second, and velocity when it crosses, oh sorry, when it crosses B is 27 meter per second. Now, okay, uh, see, we are getting these answers because we assumed that the vehicle moves towards right. Suppose it would be such that vehicle is moving towards left. Okay, suppose the vehicle would be moving towards left, that is the vehicle will cross B first. Suppose the vehicle will cross B first and then A. I'm sure you understand what I'm saying, right? Then we would have got opposite answers. Opposite in the sense, instead of A to be at A 23, we'll get A 27 and B 23, like that. Okay. Yes. Clear? If it would be in the other direction, that is, if the vehicle would cross B first and then A, then it would be vice versa. All right. But again, it's not that important really. It could be either way. So final answer is 23 and 27 meter per second. All right. That's what are the two answers. Any questions about this? Any questions about this? All right. Fine. What last answer? Vedant. 23, 27, right? The two answers are 23 and 27. આમથી આવે તો 23, 27. આમથી આવે તો 27, 23. All right. Huh. Okay, fine. We are going to end it over here. Okay, that's it. Goodbye, everyone. See you all tomorrow.